Case study: flight data analysis using Spark GraphX. The problem statement: to analyze the real-time flight data using Spark GraphX and to provide near real-time computation results and visualize the results. So, for this, let us see the dataset description. So, data has been collected from US Department of Transportation (DOT) Bureau of Transportation Statistics site, which tracks on-time performance of domestic flights operated by large carriers. The summary information on the number of on-time delayed, cancelled and diverted flight is published in DOT's monthly air travel consumer report, and in this data set of January 2014 flight delays and cancellations are being considered. So, we are going to analyze this data set that is called a flight data set using the pipeline that is called big data pipeline for flight data analysis using Spark GraphX. So, the first step in the pipeline is we have collected the data set. So, we have obtained the data set, which is a huge amount of flight data information. Now, this particular database is storing real-time flight data is being applied or being used into the database. So, after getting the data or a corpus or a big data set, we convert it into the form of a graph. So, that means the data is converted in the form of a table, and from table which will be converted in the form of a graph in the second pipeline. So, creating graph using GraphX, we will create a graph for the entire data. So, after creating the graph, we can apply various queries based on the graph algorithms. So, the queries are: we have to compute the longest flight routes, or we can compute the top busiest airports, or we can compute the routes with the lowest flight costs. So, after doing all these queries, we can also do the visualization of flight mapping on the maps, and then we will use this particular result for this. Let us see how these steps, which is called that big data pipeline, is used in doing this analyzing this flight data information. So, this particular study will have the use cases such as monitoring air traffic at airports, monitoring of flight delays, analysis of overall routes and airports, analysis of routes and airports per airline, and so on. Let us see the objective of this session about this use case or case study is to obtain following objectives. First is that how to compute the total number of airports in this data set, how to find out the total number of flight routes, how to compute and sort the longest flight routes, how to display the airports with the highest incoming flights, how to display the airports with the highest outgoing flights, how to list the most important airports according to the page rank, and list the routes with the lowest flight cost, display the airport codes and the lowest flight costs, list the routes with the airport codes which have the lowest flight cost. Let us see how these queries or how these objectives are to be fulfilled using that given data set. This data set, if we go in more detail and see the features, there are 17 different attributes are available in this particular data set. For example, DOFM, that is day of the month, DOFW means day of the week, carrier unique airline carrier code, tail number is the tail number, and F number is the flight number reporting airlines, and origin ID is the origin airport ID, origin and origin airport. Destination ID is the destination airport ID, destination is destination airport. CRS departure time is actual departure time, and departure delay minutes, difference in the minutes between the scheduled and actual departure time. Earlier departure is set to 0. Similarly, there are arrival times and actual arrival time, difference between in the minutes between the scheduled and actual arrival time, that is arrival delay in the minutes, and similarly the elapsed time of the flight and the distance between the airports. So this is the sample data set with all the 17 features shown over here for our analysis use case. So here we can see here the part of the Spark code which implements this flight data analysis using GraphX. So let us understand some of the code before we go into more detail of it. So that means first we have to create a class which is called a flight class with a with all these details which are provided as 17 different features. Then we can parse the string function to parse the input into the flight class data. So for that these functions are there, and then we will create the application name, and we have to create the Spark context. So this will create the Spark context. Now the next step is to read the file, that is the text file. Once it is read, then it will become an RDD. So the file is read, and after reading it becomes an RDD into the Spark system, and now we have to parse the RDDs into an RDD flight class using this map function, and it will create the airport RDDs with the IDs and names using this particular function. After defining a default vertex called nowhere and mapping airport IDs for printlns. So here all these details are being listed over here. Now we have to create the routes RDDs with the source ID and destination and the distance using the map function, and create the edge RDDs with the source ID and the distance and so on. So edge RDDs and vertex IDDs, routes RDDs are now created. Now we can define the graph as the airports as the vertices and the routes as an edges. So edges, routes will be the edges, and the airports will be the vertices, edges, and nowhere. So after taking them, now we will convert it into an edge RDD and vertex RDD. So using vertices and the graphs, we can now, we have computed, we have formed the graph of that particular data set. Now we have to perform various queries. So the query one is to find out how many number of airports are there in that. So just we have to calculate, we have to find out the number of vertices in the graph. If we want to find out how many number of routes are there, we have to calculate how many different edges are there in the graph. Now if we want to find out calculate those routes with the distance more than 1000 miles, so easily we can apply the filter function of this is GraphX on this particular graph. So after applying the filter function, wherein the distance is greater than 1000, it will generate a graph that is called a subgraph. Now this filter function will not delete the portions of the graph, but it will use tombstone and will generate the subgraph out of the main graph. Similarly, if we want to find out how many airports are there, so airports are represented as the number of vertices. So we have to run this particular function, that is graph dot number of vertices. So we can find out that number of vertices are 305. Similarly, how many unique flights from airport A to B are there? So we have to find out the number of edges here, and if you want to find out the top 10 flights from airport to airport, so we can find out using the graph triplets, and we can sort the flights, top 10 flights, and now we can take these 10 data out of this sorted top 10 flights. We can use it. So we can see here that there are so many number of flights from source to destination, and by taking the triplets and doing the sorting, we can easily get this information out of this particular graph. So what are the lowest 10 flights from airport to airport using same triplets, and by sorting it in the descending order, we can obtain this data also. Now if you want to find out what airport has the most in degree and or unique flights into it, then using in degrees and the join airport vertices, we can obtain this amount of information, and out of it what are the flights which are going out of the airport most of the degrees. So that also we can find out using out degree and after applying the join operation. What are the most important airports? So for that, using PageRank, what we can ranks and what not using PageRank, but ranks the airport, means it will sort and find out the airports. So graph operations output the routes where the distance between the airport exceeds 1000, that we have seen. It will just apply the filter and get this output of the routes where the distance between the airport exceeds 1000 miles. Similarly, if we want to output the airport with the maximum incoming flight, so here in degree we can find out with the maximum of it, and this will give the maximum incoming flight. Similarly, maximum incoming flights we can get using this particular piece of code. Similarly, we have to output the longest routes by doing this kind of sorting and applying on the graph triplets. So if you want to find out the cheapest airline route, then this is the code, and using this particular code we can obtain this. Now we can find out the most influential airport using the PageRank. So we can apply the PageRank algorithm over the vertices, and we can then join the airports and then take 10 and top 10 and then it will become the most influential airport using PageRank. So output the most influential airport from the most influential to the latest. So furthermore we can sort and we can obtain this. So conclusion, the growing scale and importance of graph data has given the development of specialized graph computation engines capable of inferring complex recursive properties of graph structured data. In this lecture, we have discussed GraphX, a distributed processing framework that unifies the graph parallel and data parallel computation in a single system and is capable of succinctly expressing and efficiently executing the entire graph analytics pipeline. Thank you.